Okay, good morning, everybody. This is the 18th lecture of our course, and we are looking at sorting algorithms. We have done searching, we have done linear search and binary search, and I have given you this small exercise in yesterday's class where I have asked you to take a very large sorted array and try out binary and linear search and also count the number of comparisons. I hope whenever you get a chance over the weekend or sometime in the lab, you will try to do that. So towards the end of the class yesterday, we were looking at this, the simplest sorting algorithm, which is the selection sort. And the selection sort works as follows. We are in this, in all our examples, we are going to be interested in sorting the array in decreasing order or non-increasing order because there can be duplicates. So one possible way, which is the selection sort, is to find the maximum element in the array. In general, the maximum element in the array indexed from some I to j. This j is not going to change for us. It is always going to be n minus 1. I is moving because we are repeatedly placing the maximum element in the remaining part of the array at its correct position. And we have seen how this selection sort works on a simple example. The max keeps going towards the left and it sits at the correct position. So initially 32 sits at the correct position, then 30 goes and sits next to it, which is the correct position of 30. So if you have done I iterations of the selection sort, then you know that the first I inputs are at the correct position. The remaining array is not at the correct position. They are in fact at the correct position in terms of the sorted array. So this is how the pseudo code is written, and I encourage you to develop this pseudo code, write it on a piece of paper or your text editors before you start coding your lab problems also. So while I is less than n, we want to find the max index, that is the index of the maximum element in the part of the array index from I to n minus 1. We are interested in the max value, but we are more interested in the max index because we are going to swap the array element I and the array element at max index, and then we are going to continue this, right? So this while loop which is there, which is the outer while loop, that is what I'm saying, that when you have completed k iterations of the while loop, then you have the first k elements sorted in the correct position. They are in their correct position with respect to the sorted array. And this finding the max index itself is a loop which you are aware of, and this loop will run appropriately for different number of iterations depending on the value of I. First time it runs for n minus n, it takes n comparisons, the next time n minus 1, and so on. Yeah, so there is a question here. Okay, so this is the code that we had written yesterday towards the end of the class, and this is the code for selection sort. This loop which I had written as a while loop in the pseudo code, doesn't matter whether it is a while loop or a for loop. This loop is the outer loop which runs from 0 to n minus 1. It initializes max index to the variable I, and then there is another loop which is running from I plus 1 to n minus 1 again. It updates the max index. I still have the typo in the slide. This should be max index, but yeah, so this is max index, and then it updates max index appropriately. Finally, once you have found the max index from I to n minus 1, you are going to swap this elements array of I mean A of I and A of max index, and then that ensures that you have got the ith place of the array correctly set. So this is the selection sort. Any questions on this? Okay, so something of this sort where you required to find the max index or the second maximum was required in yesterday's class, yesterday's lab. We will come to it after we are done with the second sorting algorithm which we want to cover today. and then we'll discuss how this code can be modified. The computing the max index can be modified for the question that was required in yesterday's class, yesterday's lab. Okay, so I just want to talk about a little bit of the selection sort in general. So there were questions in the last class about how good is it. So how good is it depends on what kind of input is given to you, right? So we are interested in arbitrary input, so we don't assume anything about the input. Then we would like to know, do the number of comparisons depend on the particular array values? In particular, how does the algorithm or how does this method perform when the array is nearly sorted? So this selection sort algorithm has no regard for how the input is, in the sense that irrespective of what the input is, it is going to find the maximum. It is for finding the maximum for the first time, it is going to do n comparisons. Once it has found the maximum and the max index, it is going to swap this, and then it is going to repeat this. So irrespective of what the input is, how the input is, it is going to always do n into n plus 1 by 2 comparisons. That is roughly n squared comparisons. And many sorting algorithms that you will study, at least the initial sorting algorithms that you will study, will have this nature of n squared comparisons. And the actually when we do an analysis of it analytically, in the sense of how good is the algorithm, we typically look at a worst case input. So in this case, any input behaves the same for selection sort. Selection sort just looks at every input the same way. It doesn't care about whether the input is nearly sorted or not. But in practice, many times it happens that the input is almost sorted. You have sorted inputs, but some things are incorrectly placed, and you may want to correct it so that it becomes completely sorted. And that is why there are different algorithms which are developed, and a particular algorithm that we are going to study is called as insertion sort. Again, we had discussed the method briefly yesterday. We are going to look at the exact operation of it on an array, and then implement it for an integer array in this class. So this is the goal for us to do. We are also going to show a nice simulation of comparing these different sorting algorithms, although we will study only two sorting algorithms in our course in this class, but there are many sorting algorithms, some of them which you had also mentioned in the discussion yesterday. So any questions here about selection sort? So I hope it is clear that it doesn't care about the nature of the array. It will always do the same thing irrespective of how the array looks like. Okay, so yeah, so we are now going to the second sorting algorithm, which is this insertion sort, and this is the most this is the closest that thing that represents in real life how insertion sort works. When we play cards, I hope all of you do, and spend some time playing cards and relaxing. So when you get a hand of cards, you want to arrange them in a particular order so that it's easier for you to play whichever card game you are playing. And each one of us has a typical sorting order. It may be from max to min to max, according to the suits and so on. But here it shows just everything is spades. And as you see that from 1, 2, 3, 4, 5, 6, 7, everything is sorted. The person is inserting something at that 8, and the remaining things are unsorted. So this is how insertion sort is going to work. And that is why this is the closest thing that happens in real life, which is insertion sort. In fact, all these sorting algorithms are derived from real life things that we do, and we find it useful to do when sorting different kinds of data sets. Okay, so just to see it on action on the same input that was given for selection sort, this is the same input, the unsorted input that was given to us. The insertion sort, although the end result for insertion sort and selection sort is going to be the same because it finally has to be a sorted input, the intermediate steps of insertion sort are going to be different, and we'll see how they are different. So insertion sort first looks at the single element 15, and every single element array is already sorted. So there is nothing to do. So therefore 15 is already sorted. Then it goes to 8. Recall that our goal is to sort the array in decreasing order. So with respect to 15 and 8, they are sorted because they are in the correct order. The same thing holds for 15, 8 and 3. So they are sorted. There is nothing to do as long as your array just contains 0, 1, 2, these three elements. This is sorted. When you see 12, you see that the input is not sorted because 12 is not in its correct position, and therefore you need to move this input, and the correct position for this is just between 15 and 8. And while this in the card game, we can do it very easily, insert that card there, which automatically shifts everything to the right, the remaining cards to the right. This is something that doesn't happen automatically in arrays or even in the computer sorting that you do. So you have to explicitly shift things towards the right. And this is what makes it writing of insertion sort something which is challenging but fun and non-trivial, and that is what we are going to address in the class today. So yeah, so this is the place that we want to find for 12. Then we find that now 15, 12, 8 and 3 are sorted. Now we go to the element 30 and we see that 30 is not in its correct position. So we want to find its correct position, put that element in the correct position and move everything to the right, or do it in some way such that 30, 15, 12, 8, 3 is the new configuration of the array. And then finally you lead to the sorted position. So at the end of selection sort and insertion sort, both the outputs or the configuration of the array will look exactly the same, but the intermediate steps of selection sort and insertion sort are completely different. So I want to contrast here about, so we said that when we had done I iterations of the selection sort, the first I elements were at its correct position in the sorted array. What kind of invariant? So this is called the invariant of the sorting algorithm, or the loop invariant that we have talked about earlier also. What is the loop invariant that you think is true when we have done I iterations of insertion sort? So please think about this and write
the
it.
array from okay,
just,
right.
just hold on. So hold on, whoever is speaking, I want everybody to think about it. So please write the messages in the chat so that everybody gets a chance to think about it. So the question is, when you have done I iterations of insertion sort, what is the invariant? That is, what is the thing that holds true at every iteration? If you have done I iterations, what is true about the configuration of the array after I iterations of insertion sort versus selection sort? And clearly it is not the same as selection sort because 32 has not come to its correct position. Yeah, so I see some people have written the correct answer. I would like more people to participate and write the answers in the chat. Okay, so some people don't get the question. So what I want, so I have said this, that if you do I iterations, I'll go back in the slide. So I will talk about the selection sort. So this is the outer for loop of the selection sort. If you have done I iterations, so don't worry about I being 0 or something. If you have done 1 iterations, it means that the first this I and or I should say k iterations. If you have done k iterations, if you have done 1 iteration, then the max is at it. The first element, the max element is at its at its correct position. If you have done 2 iterations, then the first 2 elements in the sorted array are at the correct position. If you have done k iterations, the first k elements of the sorted array at the end of the selection sort are in their correct position. Now this is not true in case of insertion sort. So I want you to say, is there a statement that you can make about insertion sort which says some kind of loop invariant? Yeah, so I see people writing correct answers, which is good. Okay, so assuming that everybody has understood the question, some of you have written the answers, some of you are possibly thinking or may have the answer but have not written it out. So many of you have written it correctly, that if you have done k iterations, as we see, if we have done one iteration, then we have, I have skipped some iterations here, but if we have done one iteration, 15, we know that 15 is correctly at its correct position, and it is sorted. It is not at its correct position, it is sorted. So with respect to one element array, it is sorted. If you have done two iterations, the first two elements are sorted. They may not be at their correct position in the final array. If you have done three iterations, then the first three elements are sorted. Again, they are relatively sorted between themselves. They need not be in their correct position in the final position of their array. So if you have done k iterations, the first k elements are relatively sorted and put in the sorted order, but they may not be in their correct position in their final position in the array, unlike what happens in the case of selection sort. Right, so this is what is the invariant that we want to maintain when we write our code, and this is something that you should think about, or what is it that you want to achieve in smaller parts is something that you should think about when you write code. Okay, so as I have mentioned this earlier, although the final result is the same, the intermediate steps are different, and that makes writing of this insertion sort nice, fun and challenging, and we are going to see that today. So let's look at this explicit array and ask. So anyway, when you are going through this, and as you should be able to observe that if the array is sorted, let's say it's almost sorted, there's only one thing that has gone wrong, then you are just going over the array. So if it were 15, 8, 3, 2, -1, -3, -8, but there is some 17 sitting here suddenly, then you just have to make sure that this 17 goes at its correct position, and you're not repeatedly finding out max, unlike what selection sort would have done. So this 17 would then go and sit at its correct position, but till here you have not done much work except a linear scan over the array, and this makes insertion sort more suited for almost sorted array. So let's see that when you have 15, 8 and 3, they are relatively sorted, and we don't have any work to do as long as we are seeing elements which are in the decreasing order or non-increasing order. 12 is the first place where we see that it is in the incorrect order. This is also called as an inversion. And here is where we want to move 12 to its correct position. Earlier we have said that 12 goes and sits between 15 and 8, but it is not immediate where 12 goes and sits. What we know at this moment is 12 must go before 3. So the natural thing to do is swap 12 and 3 and bring 12 at the position where 3 is there, and 3 to the position where 12 is there. Yet we see that 12 is not at its correct position because 12 and 8 are still an inversion, and therefore 12 is not at its correct position. So we still need to do one more swap, and this is something that we will achieve. At this place, the 12 is in the color black because we have we don't know that it is at its correct position. Only when we compare 12 with 15, we see that now everything is in place, because we know that everything to the left of 15, if there is anything, is going to be greater than or equal to 15, and everything to the right of this is going to be smaller than or equal to 12, because the array was relatively sorted between 15, 8 and 3, and that is why we have found the correct position for 12. and the next iteration we say that okay, now 15, 12, 8 and 3 are indeed sorted relatively between themselves. So this is how we are going to try to implement insertion sort. That is, every time we find that there is this inversion, we are going to move this element to its correct position by repeatedly swapping the element. So this is how we will write insertion sort. This is something that requires thought before coding. Again, I'm repeating that this requires thought before coding, and you need to develop this pseudo code in your mind on paper before you start writing the code. Any questions here?
Ma'am?
Yes.
Ma'am, why do we keep swapping like with the previous thing? Instead of that, can we like scan from the beginning and check if it is less than the previous element and greater than the next element? Like go until it is less than I, like, and then check and then swap it once, ma'am. Like if we keep swapping, it will further increase the iteration.
No, wait. So the question is, can we find this position? So we can find this index, but remember we cannot swap this with 8.
Okay,
That is incorrect.
yes,
Right?
ma'am. Yes.
We still need to push everything to the right. So that is why I mentioned this. This is a very good question, that the way we do it in the cards, that is put up thing in its correct position, that automatically slides the things to the right of it, but this doesn't happen automatically in the array.
Yes, ma'am. Yes, ma'am. Okay, ma'am. Thank you.
Right, so we need to swap it. There is a slightly different method where you can overwrite things by saving an element. I'll come to that method also, but at the moment we are going to implement this swapping method. Yeah, so I want everybody to think about it, that it is not easily done, that you just move this 12 to its correct position. You have to do this hard work of swapping, or some other work where you have to overwrite things. Okay, so any other question here? Okay, so what I'm going to show is a template again, as we are used to it. So this is the template. We are going to run the loop from 1 to n minus 1. Why 1? Because the array element at the 0th position is relatively always sorted with itself. So we don't care about it. So then we are going to take another variable j, which we are going to initialize with I. If aj, that is, so we can be at any particular position. Let's think about it. We are at this j where j is equal to 2. If aj is less than or equal to aj minus 1, that is, this j in the element at aj is less than or equal to aj minus 1, its predecessor, then we have nothing to do. Remember, we have to get the array sorted in decreasing order. So there is nothing to do. Therefore, we are just continuing the loop and not doing anything. Therefore, we go to the next element. This is what will happen when you see 15 or when your array index is 1, you will see that A1 is less than or equal to A0. Therefore, you will just continue. A2 is less than or equal to A0. Therefore, you will just continue. You will not do anything. Now, if you are at line 7, then you know that aj is greater than aj minus 1, which is an inversion. That is, aj and aj minus 1 are inverted. So we said we want to swap aj and aj minus 1. So how long do we want to swap this is something that will again involve a loop, and that is what I want you to think about and write. So this is something that you should slowly develop your code as you write your pseudocode. You should write these smaller parts and then say, okay, now I want to swap aj with aj minus 1 till something happens. So please try to fill this out and we will come back to the correct answer here. So this is best written as a while loop. So I encourage all of you to write a while loop such that you are going to write while something swap aj minus 1. That swap aj minus 1, even if you don't write the actual code, take temp and so on, I don't care. But you should write the while condition correct. So I am not sure if people are writing in the chat. Okay, while j greater than 0, that may not be the case. Okay, so I have got very few answers. I request people to write down their answers. Okay, so please do not write a complete for loop. I just want you to write a while loop here at line 9. While something, inside that it is swap aj and aj minus 1, and of course you'll also do j is equal to j minus 1. So let's not write a complicated for loop, just to make sure that we have the same kind of answers. Not that your for loop is incorrect. Okay, so am I audible now? Can somebody tell me if I am audible?
Yes, ma'am, you're audible.
Okay, somebody has written to me that you are disconnected. Was it disconnected in between, Kaushal?
No, ma'am.
Okay, fine. Then the student may have got disconnected. Okay, so the very common answer seems to be while aj is greater than aj minus 1, which is what I think I have also written. While aj is greater than aj minus 1, and this, and just hold on for people who have different answers, we'll come to it. So while aj is greater than aj minus 1, swap aj and aj minus 1. This code I'm not going to write down. This all of you know how to write. So just a minute. So Aishwarya or somebody, you are unable to hear me, but others are able to hear me, right? Because somebody is saying that she's not able to hear me, he or she's not able to hear me. Kaushal, can you confirm?
Yeah, I can hear you, ma'am.
Okay. Any other student? I mean, just to make sure that students are able to hear.
Yes, ma'am.
Yes, ma'am.
Okay, fine. Okay, sure. Then I think that is an individual problem with the student. Sorry. Okay. So, so this while aj is greater than aj minus 1, swap aj and aj minus 1 and j is equal to j minus 1. This seems to be correct because we are, if we look at this element 12, then 12 at when you are at 12, your j or I should have been actually equal to 3. And you ask, is aj greater than aj minus 1, which is true, then swap it, and j is equal to j minus 1. You go to 2, then it is still greater than aj minus 1, therefore you swap it, and then aj is no longer greater than aj minus 1, and therefore you have stopped this while loop. So this seems to be working correctly for this 12, which is moved from this place to its correct position, 15, 12, 8 and 3. Now, first of all, let's observe that this, if aj is less than or equal to aj minus 1 continue, is something which is redundant, because that is something that is only in our thought process. If you write this loop as while aj is greater than aj minus 1, it already means that if aj is less than or equal to aj minus 1, you will just fall here and do nothing, which is what you want to do. So you can keep this if statement here that I have kept, but you can also remove this because this is something which is not doing anything for you. I mean, it is redundant piece of code. So I hope everybody sees that. So this seems to be the working part of the code, which will hopefully solve this insertion sort business. Is it all? Is it correct? I mean, assuming that swap is written correctly. Is that correct?
Ma'am, shouldn't the case for the largest value, because that would go to 0 and then it would go to -1. So we need to
So that
consider
is what I mean. That is why the example is created such that the next index j is equal to 4. You will see that it is the element here. All of us can observe that this element should go to actually the first position of the array, that is index 0, and this will happen correctly because you are going to move everything. However, at this place there is nothing at j minus 1, right? So you are still going to ask, okay, is aj greater than aj minus 1, and you are actually going to access a of minus 1, which is an invalid access, which should not be done. So you have to be careful about this loop which says that while aj is greater than aj minus 1, keep doing j is equal to j minus 1. So this is some important learning that people have pointed out, that while aj is greater than aj minus 1 is not enough for this. So the natural thing that seems to that we should add is we should add and j is greater than 0. Right? If j is greater than 0, remember it is not greater than or equal to 0 because we don't want that j should become equal to 0, because if it becomes 0, then we are going to still access aj minus 1, which is minus 1, which is something which we don't want to access. So we want j to be strictly greater than 0, only then we want to access it. Now, is this code correct? That is, we are saying aj is greater than aj minus 1 and j is greater than 0. Is this correct?
Yes, ma'am.
Okay, so this itself is not correct, because remember the way this expression is going to get evaluated is from left to right. So even before checking that j is greater than 0, you are already going to access 0 and a of minus 1, which is something which can lead to segmentation fault. So the correct way to do this is to write the condition in the flipped way. That is, in fact, you want while j greater than 0 and aj is greater than aj minus 1. Remember, we are crucially using the fact that C is doing this short circuiting, where if j is less than or equal to 0, this condition is not going to get evaluated. That is, aj is greater than aj minus 1. And therefore, we are not in trouble in terms of accessing some incorrect element. However, if j is greater than 0, that is, it is 1, 2, 3, and so on, then we are free to access it and check this condition and then decide whether we want to enter the group. So as it is, the way it is written, this is incorrect, because it first tries to access this and then tries to check for j greater than 0. Before that, you have already done an invalid access, and therefore you will already get a segmentation fault on some systems if you are lucky. Remember that segmentation fault is something that is good. Not having a segmentation fault is something that your program is quietly misbehaving. So I hope people can see that the reason why we are doing this, j is greater than 0. First, this is crucially using the fact that C does short circuiting of these expressions when there is a logical operator and therefore we are first going to check whether aj is greater than 0. If it is greater than 0, only then we are going to access aj and aj minus 1, which ensures that j minus 1 is a valid access in the array. Right? So while this piece of code is small, and once it is written correctly, it's a very, very succinct piece of code. It still is something that takes time to write. Even if you ask me to write in the first go, I may make some mistakes. So there is nothing wrong in making mistakes, as long as you are careful about verifying your end conditions and making sure that you do your checking correctly. You can make mistakes initially, but then as you go along, you can correct them and make sure that your code is correct. So this is one way of writing insertion sort correctly. Are there questions about this?
Ma'am, a general doubt, ma'am. What are the
Yes.
cases where segmentation fault, that core dump thing, what are the cases that will come? Like I encountered that yesterday twice. Like, so can I give like, what are the cases that will come?
So whenever you are doing invalid memory access, so think of it that when you are running a program, you are given a page, or you are just, I'm making a crude analogy, you are given some space for your program to run, right? So that page is your page, or those cells are your cells in memory. If you try to access somebody else's, your friend's page, right, then that is invalid access for your program. And when you do something like scanf without an address, it means that you are going, and it still needs an address, so it is going to go and take whatever is in that array location, whatever is in that this thing, and do some invalid access. So it is likely that you are going to cross the page that you are given and do some invalid access, in which case you are going to get a segmentation fault core dumped. In case of arrays, it happens more, because you are going to you have defined an array of size 10, let's say, then you have indices from 0 to 10. If you have indices from 0 to 10, but you have this loop which is running from 1 to n, where n is a large number, and you are accessing elements of that array indexed by that I which is running from 1 to n, then it's very likely that you are doing invalid memory access, because you don't have an array which you have defined for such a large value, but you are accessing those elements of the array. Is that clear?
Yes, man. Like without arrays and scanf, like with normal variables, is it like for int variable? Are there cases where we get segmentation fault?
Okay, so I will have to look at your code. Typically, it is something which is invalid access, which is done. I will have to look at your specific code.
I corrected it, ma'am. Like I have to maybe have to check in the history. I corrected it, but I got a segmentation fault before. Maybe I'll send it in the via mail.
Sure. Please send it via email. I hope that it was not anything to do with the REPL thing which was misbehaving. But if you send me, I will try to figure out, because a segmentation fault should typically be reproducible on a Unix-based system.
Okay, ma'am. Okay.
Okay, so so what I have is, in fact, I have another way of writing insertion sort, but I would like to take a quick this thing from the class. So while we are almost running out of time, we have 15 minutes, assuming that I just overshoot by 10 minutes, and people who don't want to stay back can leave. I would like to discuss the lab questions and how possibly to organize your thought process. So would you like to do that, or shall I continue with the insertion sort? That I had another method which, again, that can be looked at in the slides, or we can come back to it on Monday's class if required. I wanted to start character arrays on Monday, but nevertheless, I think the lab thing may be useful. So I will just take this call and I'll switch to the lab thing and I will show you. But just before that, I want to show you that there is another method which is in the slides, which I will post. A small thing is about this. There is a link on this which I hope all of you are able to see the link that is there on the slide, right? Here, which is slightly later, and I would like you to go and look at this and compare the insertion sort, selection sort on different kinds of inputs. This gives a nice tool which is a web portal which allows you to look at this insertion sort, selection sort, other sorts also performing on different data sets which are random, almost sorted, and so on. So please explore this and see this when you get a chance. So when I post the slides, you please observe this link that is there and look at this. So with this, I'll stop this sharing of this session and I'll go to repl.it. I again mentioned that people who are time pressed, who have some other commitments, can leave. I will just discuss a few things about yesterday's lab and maybe just take a few minutes, 10 minutes of time, which is overshooting the class. Okay, so Kaushal, I'm just going to share my repl.it. Please tell me whether it is viewable.
Yes, ma'am.
Yeah, the browser is viewable, right? Yeah.
Yes, ma'am.
Okay. Okay, so I'm going to okay, so I'm going to talk about the question 1 first. So, okay, so are there any favorites that you want me to talk about? Question 1, question 2, question 3, then I will speak about that first so that most people are invested into whatever they want. I mean, they get to hear whichever question they found the most difficult one. I see people leaving. So, okay, question 1 and 3. Okay, so let's start with question 1. Okay, so question 1 was asking you to, this was about those hitting the digits kind of question. So, okay, so if everybody recalls, it was about the hitting of those, hitting the digits. You are given several integers and you want to find out the first index in those integers where you hit all of the digits from 0 to n. So the first thing that comes to mind is possibly keeping that all those integers in an array. However, it is not required. Just like what we did in case of histogram, we never stored the marks of all the 184 students in an array. It is not required for you to store the total elements n in an array. The only thing that you need to store is whether a digit has been hit. And for that, what we have done is we have this visited array which has indices from 0 to 9, which is exactly for the digits. And we are going to set this visited to be 1 whenever we find that that digit has been hit. How do you find that the digit has been hit? You have to separate out the digits of a number, and that is something that you already know. So you know the code to write how to separate out the digits, because that is something that we have done earlier. And we also need to know, as soon as we have found that all the digits have been hit, we need to make sure that we quit, or we store the index of the element that we have found. And indices start with 0. That is typical of arrays, and that's why it was given, so that you think of storing them in an array, but it is not required. So what we do is we have this visited array, which is from which is initialized to 0, and we also have this count which is initialized to 0. Count tells us whether all the digits have been hit, and this is something that we will increment when a new digit gets hit. So when a new digit gets hit, it means that earlier it was not hit, but it has been hit now. So then we run a loop which goes from 0 to n minus 1, which is taking the elements of the array. So this I will tell us the index. So for the first time you encounter that count becomes equal to 10, you need to store that index, and for that we have this saved index which has been initialized to 0. So then we simply scan the element. That element has been scanned in this temporary thing. If count is equal to 10, this is continue. It says that there is nothing to be done. That is, we don't want to do anything with respect to that element, because we have already seen everything. This is simply reading or consuming the extra input, because we are not storing it in an array. If you have stored it in an array, it's fine. You just have already read it, so you will not have such a code. Now is the important part of the code, that is, this is the temp value that you are processing. It could be an array element if you have stored your n elements in the array. If temp is equal to 0, that is, it's already equal to 0, and this visited of temp, that is, you have never hit this digit 0, is equal to 0, then we want to set visited is equal to 1, and we also increment the count. Else we want to extract out the digits of temp, and keep doing this as long as we don't hit this. We extract out all the digits of this, and appropriately set the visited is equal to 1, and appropriately set count is equal to count, increment the count. Finally, when if at the end of processing this input count has become equal to 10, then we save this saved index. We save I in this saved index and keep running the loop. So this loop keeps on running all the way up to n. But note that we have never saved the total elements in the total elements that are given to us. We have only an array which is running from 0 to n. So this is something that will require some amount of thought and pseudo code to be written before you actually code it out in your REPL.it screens. So any questions here or any thoughts here?
Ma'am?
Not the logic, but
Sorry?
ma'am, I had a doubt not with the logic, but this input, ma'am. When you're scanning each and every.
Sorry,
Hello?
can you repeat it?
Ma'am, I had a problem with the input, ma'am. When we run it test cases, ma'am, like how will be the input, ma'am? Space separated inputs means all the inputs will be given at the same time, or in the console, ma'am. Like we enter the first input and then enter, then again type the second input.
Yes, that is okay. That is how the input is given if you are entering in the console. Otherwise, so I hope you have seen that, you have observed that when we gave this histogram, we had this all marks, right? So this was stored like this, and it is okay to store it like this. if you write the loop, scanf will take care of reading it if you do input redirection.
Yes. But when I typed in the console for the test cases, ma'am, it was running correctly and the result was fine, good. But when I run the test cases, it was showing failed, ma'am.
Yeah, so I have already mentioned this, that yesterday there was some issue with repl.it. So there was I can't say whether that,
Ma'am, are you speaking? What?
Okay, so I just want to see how many students are there. Okay, there are enough students. So I don't know, do you have class after this? Should we just stop and discuss this in the lab, or do you still have time?
Ma'am, we have 10 cases.
Ma'am, can I share my thoughts, ma'am, for this?
Yes, please. Yes. Okay, so just a minute. Are you able to hear me first of all?
Yes, ma'am. Actually,
Okay.
your voice was disturbing for like 20-30 seconds. It went off.
I also saw some network disturbance. Okay, so I have these messages in the chat that we have class. So maybe in the interest of everybody, we will not have a discussion on question 2 and question 3. We will do it in the first part of the lab if there is interest for people to do this. But I'll take questions from students who do not have a class and can stop by. So I'll stop recording now, and I'll stop this class. I'll not discuss any new things, but I'll take questions if people have. Yeah. So somebody wanted